correct column to use for wire sizing depends on the specific wire being used and the operating temperature conditions. THHN, which stands for thermoplastic high heat resistant nylon wire, is rated for use at 90 degrees Celsius, but with an adjustment factor, it can be used in temperatures up to 75 degrees Celsius. Use the 75 degrees Celsius column when using THHN wire in temperatures up to 75 degrees Celsius. This provides a conservative ampacity rating, ensuring that the wire will not overheat. Use the 90 degrees Celsius column when using THHN wire in temperatures up to 90 degrees Celsius. However, one must apply an adjustment factor of 0.82 to the ampacity rating obtained from the 90 degrees Celsius column. This adjustment reduces the ampacity to account for the fact that THHN wire is not rated for continuous use at 90 degrees Celsius. For RTU HVAC units and chillers, it is generally recommended to use the 75 degrees Celsius column for wire sizing. This ensures that the wire can handle the normal operating temperatures of these units without overheating. In summary, use the 75 degrees Celsius column for THHN wire in HVAC and chiller units. If using THHN wire in temperatures up to 90 degrees Celsius, you can use the 90 degrees Celsius column with an adjustment factor of 0.82. Always refer to the manufacturer's instructions and local electrical codes for specific requirements and recommendations. Ampacity tables, such as those found in the National Electrical Code, or NEC, provide guidance on the safe current carrying capacity of various wire sizes based on their insulation type and temperature rating. These tables are crucial for ensuring that electrical installations are safe and comply with regulations. When selecting the appropriate column for wire sizing, it's essential to consider several factors, including the type of insulation, the ambient temperature, and the operating conditions of the electrical system. The 75 degrees Celsius column is often used for general-purpose wiring and applications where the ambient temperature is not expected to exceed 30 degrees Celsius. This column provides a conservative ampacity rating, which helps to prevent overheating and insulation breakdown. The 90 degrees Celsius column is suitable for applications where the ambient temperature is higher or where the wire is subjected to elevated operating temperatures. However, when using the 90 degrees Celsius column, it's crucial to apply the appropriate correction factors to account for the high temperature rating. Correction factors are used to adjust the ampacity of a wire based on the ambient temperature and the number of current-carrying conductors in a raceway or cable. These factors help to ensure that the wire is not overloaded and that the insulation remains within its temperature rating. In addition to temperature considerations, it's also important to consider the voltage drop in the circuit. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction and can also lead to overheating of the wires. To minimize voltage drop, it's important to select the appropriate wire size and to keep the circuit length as short as possible. The National Electrical Code provides guidelines for calculating voltage drop and recommends that the voltage drop in a branch circuit should not exceed 3%. When sizing wires for HVAC and chiller units, it's especially important to consider the operating conditions of the equipment. These units often operate under heavy loads and can generate significant heat. Therefore, it's crucial to select wires that are capable of handling the high current and temperature demands. In many cases, it's recommended to use the 75 degrees Celsius column for sizing wires for HVAC and chiller units, even if the wires are rated for 90 degrees Celsius. This provides an additional margin of safety and helps to ensure that the wires will not overheat. It's also important to consider the type of insulation used in the wires. THHN insulation is a popular choice for HVAC and chiller applications because it is heat resistant and has good electrical properties. However, it's important to ensure that the THHN insulation is properly installed and protected from damage. In addition to following the National Electrical Code and manufacturer's instructions, it's also important to consult with a qualified electrician when sizing wires for electrical installations. A qualified electrician can assess the specific requirements of the installation and can recommend the appropriate wire size and insulation type. They can also ensure that the installation complies with all applicable codes and regulations. Wire sizing is a critical aspect of electrical safety and performance. By understanding the factors that influence wire ampacity and by following the guidelines provided in the National Electrical Code and manufacturer's instructions, it's possible to ensure that electrical installations are safe, reliable, and efficient. The National Electrical Code provides tables that list the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius. These ampacity values are based on specific conditions, including the conductor's insulation type, its size, the ambient temperature, and a number of current carrying conductors in a raceway or cable. To accurately size conductors, one must understand how to use and apply the correction and adjustment factors provided in the NEC. These factors account for variations in ambient temperature, the number of conductors, and other conditions that can affect the conductor's ability to dissipate heat. When working with THHN wire, it's crucial to recognize that while it's rated for 90 degrees Celsius, its ampacity is often determined by the termination temperature rating of the connected equipment. Most standard terminals are rated for 75 degrees Celsius, meaning that the 90 degrees Celsius ampacity of THHN can only be utilized if the equipment is also rated for 90 degrees Celsius and is listed and labeled accordingly. In many cases, even when using THHN, the 75 degrees Celsius column is used to ensure compliance with the equipment's temperature limitations. When sizing conductors for HVAC and chiller units, the equipment's nameplate will specify the minimum conductor size and the required ampacity. The nameplate information takes precedence over general guidelines as it reflects the specific electrical requirements of the equipment. It's crucial to consult the equipment's documentation and follow the manufacturer's recommendations to ensure safe and reliable operation. In scenarios where the ambient temperature exceeds 30 degrees Celsius, or the number of current carrying conductors exceeds 3, correction and adjustment factors must be applied to the conductor's ampacity. These factors reduce the allowable ampacity to account for the increased heat generated by the conductors. The NEC provides tables that list these correction and adjustment factors for various conditions. For example, if the ambient temperature is 40 degrees Celsius, the ampacity of a conductor with a 90 degrees Celsius insulation rating may need to be reduced by a certain percentage. Similarly, if there are more than 3 current carrying conductors in a raceway, the ampacity of each conductor must be adjusted to account for the mutual heating effect. When applying correction and adjustment factors, it's crucial to follow the NEC guidelines carefully and to use the appropriate tables and formulas. Failure to apply these factors correctly can result in undersized conductors, which can lead to overheating, insulation damage, and even fire hazards. The NEC also addresses the issue of conductor termination temperature. Section 110.14 C1 B specifically addresses the termination provisions. This section states that the temperature rating associated with the ampacity of a conductor shall be selected and coordinated so as not to exceed the lowest temperature rating of any connected termination, conductor, or device. This means that even if a conductor is rated for 90 degrees Celsius, its ampacity must be based on the lowest temperature rating of any connected component. For example, if a conductor is terminated at a 75 degrees Celsius breaker, the conductor's ampacity must be based on the 75 degrees Celsius column in the ampacity table, regardless of the conductor's insulation rating. In addition to temperature considerations, voltage drop is another critical factor to consider when sizing conductors. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction, reduce its efficiency, and even damage it. The NEC recommends that the voltage drop in a branch circuit should not exceed 3%, and the voltage drop in a feeder circuit should not exceed 5%. To minimize voltage drop, it's important to select conductors that are large enough to carry the required current without excessive voltage loss. The NEC provides formulas for calculating voltage drop, which take into account the conductor's length, its resistance, and the current flowing through it. When sizing conductors for long runs, it's especially important to consider voltage drop and to select conductors that are large enough to maintain an acceptable voltage level at the load. In some cases, it may be necessary to use larger conductors than those required by the ampacity tables to meet the voltage drop requirements. The type of raceway or cable used to enclose the conductors can also affect their ampacity. Conductors installed in enclosed raceways, such as conduits, tend to run hotter than conductors installed in open air. Therefore, the NEC provides derating factors for conductors installed in raceways to account for the increased heat. These derating factors reduce the allowable ampacity of the conductors to prevent overheating. When sizing conductors for installations in raceways, it's important to consult the NEC tables and to apply the appropriate derating factors. The number of conductors in a raceway also affects their ampacity. When multiple current-carrying conductors are installed in a single raceway, the heat generated by each conductor can raise the overall temperature of the raceway, reducing the ampacity of the conductors. The NEC provides adjustment factors for the number of conductors in a raceway to account for this effect. These adjustment factors reduce the allowable ampacity of the conductors based on the number of current-carrying conductors in the raceway. When sizing conductors for installations with multiple conductors in a raceway, it's important to consult the NEC tables and to apply the appropriate adjustment factors. The location of the electrical installation can also affect the conductor sizing. Installations in hot or humid environments may require larger conductors than installations in cooler environments. The NEC provides guidance on conductor sizing for various environmental conditions. When sizing conductors for installations in harsh environments, it's important to consider the potential for corrosion, moisture, and other factors that could affect the conductor's performance. The type of load being served by the conductors also affects their sizing. Conductors serving continuous loads, such as lighting or heating, must be sized to carry 125% of the load current. This is to account for the fact that continuous loads generate more heat than intermittent loads. When sizing conductors for continuous loads, it's important to multiply the load current by 1.25 to determine the minimum required ampacity of the conductors. The overcurrent protection devices, such as circuit breakers and fuses, also play a role in conductor sizing. The overcurrent protection device must be sized to protect the conductors from overload and short circuits. The NEC provides rules for selecting the appropriate overcurrent protection device based on the ampacity of the conductors. When selecting overcurrent protection devices, it's important to ensure that they are properly coordinated with the conductors to provide adequate protection without nuisance tripping. In addition to the NEC, local electrical codes and regulations may also have requirements for conductor sizing. It's important to consult with local authorities to ensure that electrical installations comply with all applicable codes and regulations. Local codes may have more stringent requirements than the NEC, so it's important to be aware of these differences. When sizing conductors, it's important to consider the long-term performance of the electrical system. Undersized conductors can lead to overheating, insulation damage, and even fire hazards. It's always better to err on the side of caution and to select conductors that are slightly larger than the minimum required size. This will provide a margin of safety and will help to ensure that the electrical system operates safely and reliably for many years. The importance of proper conductor sizing cannot be overstated. It is a critical aspect of electrical safety and performance. By understanding the factors that influence conductor ampacity and by following the guidelines provided in the NEC, local codes, and manufacturer's instructions, it's possible to ensure that electrical installations are safe, reliable, and efficient. Remember to always consult with a qualified electrician when sizing conductors for electrical installations. A qualified electrician has the knowledge and experience to assess the specific requirements of the installation and to recommend the appropriate wire size and insulation type. They can also ensure that the installation complies with all applicable codes and regulations. Correctly sizing conductors also helps to prevent nuisance tripping of overcurrent protection devices. When conductors are undersized, they can overheat and cause the overcurrent protection device to trip, interrupting power to the circuit. This can be a major inconvenience and can also damage equipment. By selecting conductors that are large enough to carry the required current without overheating, you can minimize the risk of nuisance tripping and ensure that the electrical system operates smoothly. Conductor sizing also affects the energy efficiency of the electrical system. Undersized conductors can cause excessive voltage drop, which reduces the voltage available at the load. This can cause equipment to operate less efficiently and to consume more energy. By selecting conductors that are large enough to minimize voltage drop, you can improve the energy efficiency of the electrical system and reduce energy costs. Proper conductor sizing also helps to extend the life of electrical equipment. Overheating and voltage drop can damage electrical equipment and shorten its lifespan. By selecting conductors that are large enough to handle the load without overheating or causing excessive voltage drop, you can protect electrical equipment and extend its lifespan. In conclusion, conductor sizing is a complex and important topic that requires careful consideration of many factors. By understanding the factors that influence conductor ampacity and by following the guidelines provided in the NEC local codes and manufacturer's instructions, you can ensure that electrical installations are safe, reliable, energy efficient, and long-lasting. Always consult with a qualified electrician when sizing conductors for electrical installations to ensure that the installation complies with all applicable codes and regulations. Remember, safety is paramount when working with electricity. Always take the necessary precautions to protect yourself from electrical shock and other hazards. Work safely and responsibly to ensure the safety of yourself and others.